Gentles and ladymen, I'm Spiro, and I'm not a wizard. Today is episode 4 of our Learn Commodore 64 Basic series, and we're going to cover user input. First off, what do you think of my new C64 layout? I just did an edit on the kernel and the basic ROMs and changed the colours, changed it to lowercase, changed my ready prompt. Think it looks kind of cool. Hopefully it's still legible for you. Let me know if there's a issue with the contrast and so on. Let's get into it. The two commands we're going to cover today are input and get. Now, they both work to receive input from the user, from the keyboard, but they work in quite different ways. Input will read keys and display them back to the user and will keep going until you press enter. Get reads one key. It reads the keyboard buffer in memory, and if a key isn't currently being pressed, it won't return anything. So they work in quite different ways. And get is only reading a keyboard buffer, so it's up to you to display the response back to the user. So when they press a key, it's up to you to print that back out on the screen to show them that it was accepted. So a little bit different in the user friendliness department. There is also another thing that both of them share, which is that they can't be used directly. Now, when we say a direct command, that is a command we're entering here on this screen. That is, if I type in print hello, I'm entering a direct command for it to execute. Whereas if I had put a line number before that, that's not a direct command, it's an indirect command because I'm adding it to a program listing. To get the Commodore BASIC to execute that command, we would then have to run that program. So that's what we mean, the difference between direct and indirect. So most commands you can run direct. Input and get you can't. So if we want to receive so the input command takes at least one, it can take one or two parameters effectively. Well, and parameter may be the wrong way of putting it, but we want to say get the user input and store that in a variable called a string. We get told if we haven't put it in a program listing that it's an illegal direct error, so we can't run that. And the same if we try the get command. So we have to put those into a program for them to work. So there's one thing you need to put in for the input command, and that is a variable to receive the user input. If we do that and we run it, we'll discover a quirk of the input command, which is that it prints a question mark and a space regardless. You can't get around that. Well, you can't without doing a specific poke, which then kind of, it's messy. I'm not going to tell you how to do the poke, because that might poke things. So we have now been prompted to enter in something on the keyboard. So we can go blah 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 blah. Actually, there is another quirk, which is if that has a colon in it, it's going to be messy. So let's put random characters in there, and it's happy. If we print a string, that's what we typed in. Now, it can also be digits. Alright, they're digits, but they're not a number, because we have input a string variable. Now let's change that to a numeric variable. Alright, I'll just clear the screen here so we get rid of that junk. So our program is input A. So now this is going to be receiving a number. So still looks the same, but if we try and type in something that's not a number, it's going to turn and go, I don't like that. Please try again. So we can now, so if we enter in now a number, it's happy with that. If we print A, which is the variable that that input went into, you'll notice that there's a space at the beginning of it. And if you go back to the previous lessons, you'll know that is now actually a number. So it's not a string. If we had put input a string and treated it as a string, and we went 9393, okay, so now we have a string. We print a string, there's no space at the beginning. Yeah, so it does a little bit of checking for what you type in, but not a lot. If we run that program again, so we're input a string, so it now should accept any character on the keyboard, and we type in interesting things or uninteresting things, but we want to press backspace and we go, oh, actually I didn't want that. I wanted to put hi there. The result of what we get might not match what we wanted. It did in that case. Let's try pressing delete a lot. Let's do some cursor movement and then press return. It looks like it accepted it, but we didn't really get what we thought we were getting. So there is another quirk I found at one point, which I'm not sure I'm going to be able to replicate here, but if we type in, say, test, a colon I've found sometimes gives me issues. Let's print a string. I'm not sure why that is. It's very strange. The colon character, and this isn't something I've covered in the previous videos, I don't think, but the colon is basically a command separator, so you can put more than one command on a line. So we can do a print 1 colon print 2. So they're two separate print commands, and this says, okay, so that's the end of one command, I'm going to start another command, and it'll do that. But for some reason, if you put a colon inside what should be a string of random text, input doesn't like that. Now there's another thing we can add to input, which is a query prompt. So we can say, what's your name? And we've got to put a semicolon. It's not like the print statement where the semicolons are optional, and it's not a separate parameter, so we can't put a comma. It has to be a semicolon. Okay, so now if we run that, you'll notice it's still got that question mark and that space at the end of the prompt. Yep. But this time at least we've specified, we've got a prompt up, so we're asking the user to enter something and they know what's going on. So we can print that, and then it's received that. So that's the input command. At a minimum, we need the input and a variable to receive the input, and optionally we can have a prompt string that gets printed up. Now get works a little bit differently. Get, as I mentioned, just reads the keyboard buffer in memory. So let's create a new listing. So it works on the fly. If we have a command that says get a string, and we run that, we go straight back to our prompt, because it literally just reads the memory location and then it moves on. So if we print a string, we weren't holding down a key, so the string is empty. And because it's only reading a keyboard buffer, there is no option to put in a prompt. Now just pause then, because I just forgot something about input. I'm just going to take a detour back. This might mess up the indexing titling for YouTube. Input can actually be used to input multiple variables separated by commas. So what happens is there's two ways of entering those in. Because we're doing numbers, I'm just going to say 4, enter. Now we get 2 question marks to say it's expecting more. 5, 6, 7. Okay, so it's received those 4 inputs, those 4 variables, and it's put them into their own, it's taken those separate inputs and put them into their own variables. Now there's another way of entering in if you know there are multiple variables, you can actually separate them by commas. Oh, I don't know if that's going to work now that I've pressed backspace. Let's find out what happens. Print A, comma B, comma C, comma D. There we go, 5, 6, 7, 8. So that's the option, is that you can press enter between each one, or you can separate them by commas, and then that will separate them into the variables. Alright, let's get back to get. So, where was I with get? Get only reads the keyboard buffer in memory. So it's up to us to enter in a prompt string. So we would have to say print, let's work with me on this one. Enter number 12999 space. So this time there won't be any question marks or any spaces added on, so we've got to add all that, and we're going to put a semicolon at the end of that prompt string because that's where we want the cursor to be ready to, so that we can print back the user feedback. Now we're going to enter it in for the purposes of this demonstration as a string. We'll see how we go. So because it reads the keyboard buffer, if you haven't pressed a key, there's going to be nothing in the buffer and you're going to get a blank string. So what we want to say is if a string equals a blank string, then it's go to 20. In other words, read a key. If we don't get a key, wait to read another key. And in fact, there's another little shortcut of the then statement, which is we don't even need that go to. That saves us a few bytes. So we can say that if you see a then and then a line number or a number, that's basically saying if that matches, if that condition matches, then go to this line number. So oddly, this is a sort of a negative match. So if there's nothing, then it has matched. So we've now, when we get to line 30, we'll only get to line 30 if a key has been pressed. Yeah, so let's just prove that for you. Print a string. Right, we'll just do a quick enter a number. I'm not doing any checking, so it doesn't need to be a number, and it prints out the character I entered. So it is going to be important that we print out the character that we enter, because if we hadn't done that, if I delete line 30, that was just to show you that that was the only time it moved on. If I pressed a key, see, it didn't respond, it didn't print that back, so we need to do that. But what we want is we want to add a condition to say, have they actually entered a digit? We don't want to accept the input if it's not a digit. So let us go to our lovely PETSCII screen display character chart that we know and love. There'll be a link for that in the description below. What we want to do is we want to accept only this range of characters, 0 through to 9. So the decimal code is this column here. So the decimal code for 48, in fact we can probably do this without needing to know the decimal code, but just so you know, the decimal code for 0 is 48 and 9 is 57. I'm going to work around that actually. We want to accept 0 and 9. So they're in consecutive order. We don't want to accept anything less than 0. And we don't want to accept any character that's greater than the 9. So our line 30, before printing something back on the screen, we want to validate that input. So let's say if a string is less than 0, yeah, and a string is greater than 9. An interesting quirk of BASIC is that we can do greater than, or like effectively a numeric comparison between strings. It's doing the background magic to say if the character code for what you entered matches the character code, or is less than the character code for 0. So it's going to use these decimal representations. So when we say that 0, it's going to compare it numerically to 48. And it will be, we can do it ourselves using the character string if we wanted to. Or I should actually say character string of a string, and that'll convert it into the that'll get the numeric representation of the string we entered. That might be TMI for now. Let's focus on if the character they entered is less than 0 and it's greater than 9, we don't want it. So we want to go back to 20. Let's list that. So we've now got our prompt string. We're getting a character. While no character is pressed, it will go back to get another character. If the character we entered is not a digit, we don't want it, so go wait for another character. So if we run that now, nothing will be printed out just yet, but take my word for it, I'm pressing the letter H at quit. Actually, that was probably a bad example because I'm only waiting for one character. But if we print a string, oh no, I haven't done enough yet. Sorry, I'm jumping ahead of myself. We haven't done anything with it yet. So what we want to do is, oh no, it should have gone back, shouldn't it? If a string is less than 0, it can't be less than 0 and greater than 9. I'm a muppet. You should have been shouting louder. Or. Now I'm going to press J because that's a different character. Ah, there we go. That makes more sense. So now I'm pressing letters, it doesn't like it. The first time I press a digit, it's happy. So if we print a string now, I did indeed press the number 7. Okay. Sorry, I'll try and listen better next time too. I heard you shouting. What do we got? So now we've got a digit. But we want to accept up to 3 digits. That's the only way we're going to get a number up to 999. So let's say if we now have to add that one the A string, which now is only going to contain one character, as we're going through a loop collecting key presses, valid key presses, we will then have to start adding those into another string or another variable to collect those. So let's say we want, let's add an n string, because that'll be the number that we're collecting. So we want to say, once it gets to line, if it passes line 30, then it's got a number and it's a valid character. So we want to say we've got a valid character, let's add it to our string. But we only want to add it to our string if it is if we haven't collected too many digits. Does that make sense? Let's do the digit counting second. Okay, let's do n string equals n string plus a string. Now I actually do want to do the checking now, don't I? Otherwise I would have to do another check for, say, waiting for them to press return. Actually, let's do that too. Let's add a check before the numeric check to say if the character they enter is, and because so now we're going to work with the character string, because we now want to say have they pressed enter or return, and there's no way we can have enter or return as a character in a string. So we have to look up here and say, all right, what is the return? The character code for that is 13 in decimal. So we have to say, have they pressed character 13? If they have, then let's just end the program at that point. Let me see, what do we got? So we get a character. If they press enter, we'll end the program, they'll be done. We don't want to add that to this variable. That's no good to us. If they haven't pressed enter, have they pressed a valid number? Cool. If they have, we'll move on to this part. So actually we want to print it out. Do we want to print it just yet? Maybe not just yet. First off, we want to check if the, I'm not sure how I'm going to go for my rambling time here. There's a couple of ways of doing it. We can keep a counter, and we can increment the counter each time and say, I've got a valid character, increment the counter, and then only continue to accept characters while that counter is lower than the maximum. Or we could compare the length of the string. So we could we could compare the length of the string of the receiving string, which in this case is n string. Let's do that. So we've already got a variable. Let's not create a counter. You could do that if you wanted. So we've got a valid character. We want to add that character we might change the order of this, but let's just put in if the length of end string is equal to 3, because that's the maximum number of digits we're going to be able to hold. Oops, then end. $60, go to 20, which is the line which gets the next character. We haven't printed the character back out to the user yet, and we only want to do that after line 30. So let's add in line 35, print a string, and we'll put a semicolon at the end of it so that it stays on that same line. Alright, what have we got? Print a prompt. Get a character. Is that character enter? If it is, end the program. Is that character between 0 and 9? If it isn't, get another key. If it is, print that character to the screen. Then add that character to our end string. Now, if the length of end string is 3, we'll end the program. If the length of n isn't 3, it'll continue. It'll get to line 60. Line 60 will say, go to 20, and it'll do it again. Now, in fact, what we could do is, instead of ending the program here, let's say go to 100. And then line 100 will be print you entered yo entering baby. You entered end string. We probably do want to also insert let's make that line 110, and then line 100 will just be a print, because if once it receives that third character, it's going to stop receiving, but it will still be on that line. So we want to print a blank line before we print what they entered. Let's run that and see how we go. I'm entering letters. It's not accepting any of them. I put a digit. First one, 3, 2, 9. Beautiful. If we run that again, I can press just a single digit and press enter, but it ended the program. So maybe let's change that to 100 as well. And then if we enter in a single digit number, you entered 6. There you go. I hope that makes sense. I know that was a lot to take in, but it does show the difference between and the complexities that you have to go through with the get versus the input. Input is horrible for what it accepts. Get is horrible for the amount of work you have to go through to get anything, any good results as well. But you get more control with get, and that's kind of why I tend to use it. I tend to have, when I'm entering in strings, like say for example, if I've got a routine that is reading for a file name, I will only allow 16 characters to be entered. Once they can't enter it anymore, because a file name can only be 16 characters on the disks. So, but whereas this code, in this simple example, as soon as you enter in that last character, it ends and it says, yep, cool, I've got what I wanted. If you made a mistake, you can't go back and delete it. So my routines tend to also check for the delete key. In the same way that you check for return, we can look through this and we can say, what's our delete key? Here it is. So decimal 20 is the delete key. So we would say if character string equals, if a string equals character string 20, then take care of deleting a character. And then that gets a little bit complex, because you've then got to say, okay, well, I've already collected the string or the character that I now want to delete, so I've got to remove that. So you'd have to remove that character from end string. And if you go back to a previous episode, you would have learned about left string and right string. So you might say, okay, well, I want the entire string except the last character. So you might say left end string, comma, len end string -1, for example. So you would chop off that last character. But then you've also got to, where we're printing the character, you've also then got to make sure that that is deleted on the screen. And there's a way of doing that. This is something I'll get into a little bit more in a future episode, but just quickly, if you type in print and you do an open quote, you can now press some control keys and they will end up, you'll see funny characters now appear, but the way of moving around the screen is that you can now press the arrow key. So if I press left arrow, it's going to print what looks like an odd character, but when it prints it's going to move the cursor back a character, because it's effectively it's gone back. I'm not sure why I do the back. I tend to go left, space, and then left again, and then close the quotes, and that will basically make the cursor go back, space, and then when you press space it'll move forward a character again, so then you go back again. It might be worth playing with. I either did at some point and it didn't work for me, or I'm an idiot and I haven't tried it yet. But you could also print, so you can't print the backspace key, that's one of the control characters, but you could do control string, character string 20, and that might well print it. I don't know, have a play. So yeah, these loops can get long, especially if you want to, because some of the characters are separated here For example, if you only want to accept words, then you can say, okay, I want everything from A to Z, but I also want them to be able to press space. So you've also got to account for this this character as well. If you want to allow them to do words, letters, numbers, and spaces, you've now got to say, okay, well they can enter in this, and they can enter in this range. They can't enter in that range, but they can enter in this range. So you can end up with multiple lines of if statements to say, okay, does what they entered match this? No. Does it match that? No. Does it match that? No. And then once you've got something that is valid, then you'll add it, you'll collect it, and keep going through your routine. I hope that made sense. Please ask questions. I will, if it's not clear, I'll try and explain it better, or if need be, even make another video which explains it a little bit differently. Yeah, everyone learns and understands things differently. So I'm as I've said, I'm not trying to take anything for granted, but I understand that sometimes things like this can feel a little overwhelming, especially if you've got an idiot teacher like me who doesn't plan anything and I don't know how good I am at explaining things. Let me know. But as always, thanks for watching, and thanks for your support, and thanks for all the great comments I've been getting on the series so far. I will be slowing it down. The first 3 episodes came out daily, and I think that was a bit too much. Let me know. I think that I might try and release an episode weekly, because I still want to do and keep releasing other videos as well, not just this series. So keen to hear your thoughts. Please leave them and any other comments below, and I'll see you in the next video.